This is one of many models of the NRF24 radio module. Have you ever felt frustrated by not getting this module to work? Because I have, a lot. So let me show you what problems you could encounter with this module and how to solve them and improve your connection. Also to see what new modules we have. We will talk about noise, SPI problems, supply sensibility, amplification and antennas. So guys, let's get started. Do you want professional PCBs like these ones that look so good? Then use the services of PCBWay. You can select the board size, any solder mask color that you want, including some exotic purple, or if you want, the matte black and green. You can select the thickness, and the PCB could be from 2 up to 14 layers for some more complex designs. The finish quality is so good, and if you want better connectivity, you could also select the gold finish for your pads. The ordering process is so easy. Just go to PCBWay.com, quote now, insert your design settings and the amount of PCBs, upload the Gerber files, and order now and receive the PCBs in just a couple of days. What's up my friends, welcome back. These are all radio modules. And they are actually the same module, the NRF24 L01. But as you can see, over the years, its design evolved and got better and better. But even so, using this module can be frustrating. I've used this module a lot, and you'll understand why it's still my favorite. I've made several radio controllers, and all these are homemade and based on the NRF24 module. I've also made a lot of other radio connection projects and so on, and they all work now. But I had a lot of problems. And in this video I want to go over each problem and the possible solution. Around 30% of the comments on my NRF24 module videos are about frustration with these modules because it doesn't work. So why is that? Problem number 1. Connections. The NRF24 uses SPI and it needs 7 pins. 2 for power, 2 for MOSI and MISO, and then we have the CE, the CNS and the clock connection. So obviously this results into having a bunch of wires, so the chances of errors are already high. Also the basic NRF24 module pin shape is not compatible with any breadboard. In my case I had to make these adapters, so I could make my tests. Like this I can put the module into the adapter and then the adapter on the breadboard. And if you want you could buy such adapters and they already have the power regulation on the PCB, and that's another problem that we will talk about. So my first recommendation is to make a PCB instead of separated wires. At the same time, if you do use wires, you should make them as short as possible. And why? Well, that's because of the second problem, noise. And I'm not talking about the radio noise of 2.4 GHz. I'm talking about the induced noise over the SPI communication. So it's not the noise over the signal between the antennas. It's the noise between the module and the microcontroller. Because SPI is very fast and sensible. For example, with my Arduino drone, I've spent months figuring out why the radio connection was interrupted all the time. And one reason was the current peaks from the DC motor tracks that were inducing noise over the SPI tracks on the PCB. So make sure that the SPI connections are not passing over or near power tracks, especially if those tracks are oscillating with PWM or other kind of oscillating signal. With one project I've tried to make some sort of Faraday case around the tracks using some vias. But that wasn't a good idea, and it created even more noise. The best scenario is to avoid other tracks overlapping with the SPI ones. And speaking about Faraday cases, the designers also realized that the module has noise problems, so you could now buy a module like this one. It has the radio module enclosed inside of a metal case in order to avoid any outside noise. And that's the way to do it, not adding vias around it. Anyway, the final recommendation for SPI noise is to try wrapping the ground wire or the track around the MOSI and the MISO wires, especially on the breadboard tests, and this method helped me a lot. Wrapping the ground wires around the SPI wires reduces the noise a lot, from other tracks or wires, but even the noise between the SPI wires as well. Okay, so for the SPI noise you should 1. Use as short as possible wires or PCB tracks. 2. Place the radio module as far as possible from the power switching tracks, even outside of the PCB if you can. Point 3. Try insulating the radio module with some sort of Faraday case. And point 4. Wrap the ground wires around the SPI communication wires. Okay guys, so the third frustrating problem is the power and supply. These modules are very sensible to their supply, and they all work at 3.3 volts. With more than that you will burn it, and with less it won't work well. One of the most common voltage regulators used with these modules is the AMS1117. It could give you a very stable 3.3 volts output. One problem I found with this IC is that it has a 1.1 volts voltage dropout. So if your project works with LiPo batteries, which are 4.2 volts, the maximum voltage this IC could give you is 4.2 minus 1.1, and that will be 3.1 volts, which is not enough. And that's a problem that I had with my mini drone project, because I wanted to make it work with a small LiPo battery. So I've also tried the HT7333 regulator, and this one has only 100 mV of voltage dropout. But another problem to have in mind is the power consumption. Usually the NRF24 could use up to 20 mA when working, but it will use a lot more if you have the amplified one, with an antenna. The HT7333 regulator has a maximum output of 250 mA. So if you use it with your entire PCB, that current will be divided between the microcontroller, the switching MOSFETs, the LEDs and so on, and also the radio module, so the power might not be enough. Actually, with the HT7333, I still had some problems. That's why I always try to use the AMS1117 and have a higher input than 5 volts, so the voltage dropout won't affect it. The worst scenario is to use switch mode regulators such as these ones. If you use a buck converter to get 3.3 volts, you will have a lot of noise and the voltage won't be stable enough, so the linear regulators should be the solution. These radio modules are very sensitive to voltage changes, that is recommended to add a 20 up to 100 nanofarad capacitor between its ground and the 3.3 volts pins to reduce the voltage oscillations. This is a very effective solution, so I do it all the time. You can solder it directly to the module, or in case of an SMD version, you can add that capacitor close to the module on the PCB. So guys, for the power problems you have linear regulators with sufficient current output, very stable 3.3 volt supply, and adding a capacitor close to the 3.3 volts connection, and never use the switch regulators with this radio module. The next problem might be the antenna or the power amplification. When I first started with these modules, I was using this one, which is the most common one. But for better connection and a higher range, I always recommend you to use the power amplified one with an antenna like this one, especially for the transmitter. As you can see, this one has on the PCB the NRF24 IC, but also a power amplifier, which is the RFX2401C. And instead of the PCB antenna, this time we have an external antenna of around 10 centimeters. For the radio controller project this works great. But when you want to make a smaller project such as the mini drone, you need a smaller version. So for that we have the SMD module that could get soldered directly on the PCB. Actually my Arduino board already has the SMD pads for that, in case that you want to make some tests with it. And you can also find the NRF24E LE, which is a different version. But this SMD module doesn't have the power amplification, or at least it didn't till a few years back, because now we can also find the SMD version of the power amplified module like this one. It's also very small, and the best part is that it also has an IPEX connector. So you could use the PCB antenna or connect an external one using this connector. All you need is this small adapter, and then you could screw an external antenna, which could be of different sizes. With this configuration, I was able to get a steady connection up to 2 kilometers, which is crazy. And you know what? With this other huge antenna, back at my father's house in the village, I had a good communication up to 5 kilometers, which is even crazier. I recommend you to watch the iForce2D channel, where he got up to 30 kilometers using this kind of antenna, and that's why I love these modules. They could have a decent range, and they are quite easy to use. And that's the last frustration problem that you could have, the code. Once you download the Arduino library, all you have to do is to define 2 pins and the basic settings. And those 2 pins are the CE and the CNS connection for the SPI, and they can be any digital pin of the Arduino, because the rest are hardware communication pins, and they must be pins 11, 12 and 13. One problem that you might have is that you are using a different pipe code for the transmitter and the receiver, so make sure that you have the same code. And then we have a few functions to set some configurations. You can set the speed if you want, and obviously, the lower the data transfer speed gets, the less errors you should have, so I always keep my speed at 250 kbps. And basically that's all you should know about these modules. We have a few versions with different sizes, they are sensitive to noise, you need short wires connection, noise insulation, and they are very sensitive to the power input. Also with the amplification and a decent antenna, you can get to very long ranges, and you can also control some parameters in the code. Check my Arduino or the STM32 tutorials on how to use those microcontrollers with these radio modules. And by the way, don't buy this module. It's advertised as a compatible NRF24 but is not. I wasn't able to make this work, so have that in mind. I hope that you now can make your NRF connection to work. If you have learned something new, consider giving me a like or comment below. Thanks again and see you later, guys. So guys, did you like this video? I hope so. Okay, so look, I would really like to thank you to all of you for the support, especially for those who are supporting me on Patreon, because that's a really nice thing to do. And if you can't support me on Patreon, well, all you can do is to just like my videos or comment below in order to get more activity on YouTube. That will really help me. And if not, you have all my links below for my shop, for my website, if you want to buy my t-shirts and so on. So thanks again and see you in the next video.